So, the first two are really easy. Why?
Because they're already common denominator.
Right, already have a common denominator. So, I have 3x minus 4 over x plus 8 and 2x plus 3 over x plus 8. So once you have this, already have the common denominator, you just leave it, right? And then just combine like terms. 3x plus 2x is 5x. And negative 4 plus 3 is a negative 1. And you're supposed to tell me the restrictions. So you have to say x cannot equal negative 8. You need all of that to get full credit. Any questions? All right, number 2. Also, an easy one because we already have the common denominator. So that doesn't change. I just leave it. Then I subtract like terms. So x minus 5x is a negative 4x. And 5 minus a negative 2 is 5 plus 2, which would be 7. X cannot equal what? Negative 3 over 2. If you're not sure, just set 2x plus 3 equal to 0 and solve for x. And you'll get negative 3 halves. Okay? Any questions? So the first two tomorrow should be pretty easy as well, right? They'll just have a common denominator for you. All right, 3 and 4, we have to get a common denominator first before we can add or subtract them. So when we have a problem where we don't have a common denominator, we need to factor denominators. Don't factor any numerators until after you add or subtract the two fractions. Okay? So this is a regular trinomial. There's no GCF. It's just x squared, so it's always x times x. So all I got to do is worry about factors of negative 12. So this is what I'm doing in my head. Or you could write them down. These are all the possibilities. And then I add those in my head. And I'm looking for the answer of negative 1 when I add those. That would be the last one I wrote, right? Positive 3 plus a negative 4 is a negative 1. Positive 3 times negative 4 was the negative 12. I wrote that part out already. All right? So plus 3 minus 4. Okay? So my common denominator then is whatever shows up. I write down. So I see an x plus 3 show up, I write it down. I see an x minus 4 show up, I write it down. I see an x minus 4 again, same exactly. I don't have to write it down again. I already wrote it once, I don't have to write it more than once. So that's my common denominator. Any questions? So, looking at the original denominator of the first fraction, and looking at my common denominator, what do you notice? They're the same. I don't have to do anything to it, do I? So do I do anything to the x plus 4 up top? No, it stays the same. Now the second denominator was x minus 4, and now I got an x plus 3 and an x minus 4. So what did I do to the second denominator? I multiplied by x plus 3, right? So I have to do that to the 2x, the original numerator. I have to multiply by x plus 3. There's my two fractions now, rewritten with a common denominator. Right, Ozer? Right, Colai? Come back to me. Thanks. Any questions? Now, before you can do this addition, you got to do multiplication, right? Order of operations. So I have to distribute. Okay, so that changes to 2x squared plus 6x when I distribute. So, combining like terms, I've got no other x squared, so it's just 2x squared. I got 1x plus 6x, those are like terms, so that's 7x. And I got 4 plus nothing, so that's 4. Now's the time I should try to factor, okay? So if I were to factor this, there's no GCF, and there's a 2 here for A, so I multiply the 2A times the 4, the C, and I get 8. Are there factors of positive 8? Those are all the factors of positive 8. Do any of those add up to 7? No. So I can't factor. I'm done. You don't even have to write any restrictions for this. Simple. Okay, question? Yes, great. 1x plus 6x. Just combining like terms. Anything else? Question line? Okay. Number 4, we're gonna do the same way. Find the common denominator. So I've got x squared minus 1 and x plus 1. So I can factor this as a difference of squares. Square root of x squared is x. Square root of 1 is 1. 1's addition, 1's subtraction. So I write down whatever shows up. If I see an x plus 1 show up, I write it down. X minus 1 shows up, I write it down. X plus 1 showed up again, don't have to write it down again. So is it x plus 2? I'd have to write it down, because it's different than the other two, right? So that's my common denominator for my two fractions. Again, this first fraction's denominator is the same as my common denominator, so nothing changes for my first numerator. The second denominator was x plus 1. I multiplied by x minus 1, so that's what I have to do there. Why put x there? What should I put there? 2. Sorry. All right. What if this was, x plus 2? How do I multiply x plus 2 and x minus 1?
Foil.
Foil it, right? So you might have to foil them all. You might have a binomial there instead of single numbers. So here we're going to distribute again first before we subtract. So that's a 2x minus 2 when I distribute the 2. So my denominator doesn't change. All right, now I combine like terms. What's x minus 2x? X minus 2x. Negative 1x, right? Or just negative x. What's nothing minus a negative 2? Nothing minus a negative 2. Positive 2, right? Minus a negative addition. Can I factor that numerator? No. So I'm done. Man, I made those easy for you. Hopefully they're that easy tomorrow, huh? Yes, sir.
Oh, why did you do the X minus one instead of the X plus one? When you distributed the two and two?
The original was X plus 1, so that's there.
Oh,
So I multiplied the bottom by X minus 1, so that's why I multiplied the top by R.
all right.
Right? Okay. Any other questions? All right, so those two, you're gonna have to find common denominator first. All right, number 5 is one of those complex fractions. And I've got an addition problem in my numerator. And then I got just a fraction in my denominator. So I have to do that addition problem first. Okay? Can I factor either of those? Can I factor 2x or x? No. So what shows up? A 2 and a x. That's my common denominator. The original was 2x. The common one's 2x. So my numerator, first numerator stays 1. The second denominator was x. I made it a 2x. So what do I got to do to the 3? Multiply by 2, right? Well, when I add 1 over 2x plus 6 over 2x, I get 7 over 2x, don't I? So now I have a fraction divided by a fraction. So I change it to multiplying by the reciprocal. Not equals, sorry. Times. And I flip that bottom one. All right, so there's my problem. You with me so far? All right. Now, when it's multiplication, I don't need common denominators. I just need to factor anything I can factor. Is there anything I can factor?
No. Yes.
Yeah, the 2x minus 2 I can factor. How do I factor it? Take out the 2. Yeah, it's got a GCF, right? 2x divided by 2 is x. Negative 2 divided by 2 is negative 1. Do you see any factors that are the same? Yeah, the x minus 1, right? So those, yeah, if we were trying to do asymptotes and graph and stuff, yeah, there'd be a hole there, right? But we're not doing that right now. So the top is just 7. And the bottom is 2x times 2, which is 4x. Okay? So way over here on the left is what it started out being. We simplified that to 7 over 4x. Any questions? Simple, isn't it? Very easy, right, Grace? Good. All right. 6, 7, and 8 is from the section 8.4, finding our asymptotes. All right. So 6 is written in the form that you could just look at it and find the vertical and horizontal asymptotes. Okay? So underneath, I got a spot for vertical asymptote, and that's what makes the denominator 0. So what number makes that 0? Negative 8, right? Horizontal asymptote is whatever's out to the right of that fraction, which is what number? Negative 1. Okay? Domain goes with your vertical asymptote, because that's your x's, right? Range goes with your horizontal asymptote, that's your y's. So the domain, you know, if you do it like you're supposed to write it all out like this. But if you just write x cannot equal -8, that's okay. That's roster, no, that's not roster, that's set builder notation. So all y values such that y is everything but -1. Yeah, if you just write x is not equal to -8. I was just showing you the proper way to do it. But you should put x cannot equal -8. Just don't write -8. All right? That's telling me the domain's just -8. Really, the domain's everything but -8, right? And the range is everything but -1. All right. Number 7. Okay. So I'm asking for zeros, vertical, asymptote, and horizontal. Okay, so what we do to figure this out is we factor what we can factor. All right, so I can factor both top and bottom. Also, for horizontal asymptote, what do I look at? Looking for degree, right? What's the degree of the top? 2. What's the degree of the bottom? 2. Will there be a horizontal asymptote? I've heard some no's and some yeses. Which one is it? Yes. Why is it yes? Because the degrees are equal, right? When the degrees are equal, there is one. When the degree of the top is bigger than the degree of the bottom, there isn't one. You listening? We went through this more than once. When the degree of the bottom is bigger than the degree of the top, there is one, and it's always what? 0, yeah. Okay, that's what you look at. Degree is what the degree of the polynomial is. These are both of a degree of 2. If they're the same like this, there is one. If the top one's bigger than the bottom one, there isn't one. If the bottom one's bigger, it's y equals 0. Okay? So since we're talking about these, we'll just go ahead and do it. When you do this, you take the leading coefficient of the first, or the top one, divided by the leading coefficient of the bottom one. Well, what's those two numbers? 1, right? So it's 1 divided by 1, which is 1. So that's my horizontal asymptote. Okay? Factoring the numerator, it's a regular trinomial. There was no GCF. So to get the x squared, it's got to be x times x. Factors a -5. There's only 2 of them. -1 and 5, or 1 and -5. Which one do I want? -1 and +5. The bottom's the difference of squares. 2 terms, they're both perfect squares, a minus between them. The square root of x squared is x. The square root of 9 is 3. One's addition and one's subtraction. Okay? So the zeros are what make the numerator, the top zero. So what number makes this binomial zero? 1, right? So one of my zeros is 1, 0. If you're being technical, it's a point, right? The zeros are where the graph crosses the x-axis, right? What number n for x makes this second binomial 0? -5. If you just put 1 and -5, that's fine. I'm just writing it out how the proper way. For the vertical asymptote, it's always what makes the bottom 0. Okay? So what are those numbers, Kennedy? And that's an equation of a vertical line.
Are you actually asking?
Yes, I am.
Wait, are you asking again?
What makes this 0 and that 0?
Three.
Is it that hard? No, it's pretty easy, isn't it? Okay. The last one. The degree of the top is what? 2. What's the degree of the bottom? So is there a horizontal asymptote? No. So for HA, there isn't one, right? Zeros. And, oh, there must be a hole, huh? All right, so what I have to do is factor that numerator. Factors of -3 are -1 and 3 or 1 and -3, which pair adds up to 2. All right, -1 and +3. And what did I tell you the trick is for these if they got, oh, that wasn't really, never mind. That was for the other ones when we had an equation. But anyway, do we have a hole?
Yes.
Why?
X plus 3 cancel.
Yeah, because of the cancellation of the x plus 3. So what number makes that a 0?
And
No, this, for the whole, -3, right? So the hole's when x equals -3. All right? So if we had to graph it, we could figure it out. Right? The 0 is what? 1. We're done. Any questions? Pretty easy, right?
yes.
If you can factor, which most of you can. Hopefully tomorrow, all of you will be able to factor.